Here are 3 problems from the 2.1, 2.2 skills check quiz that could definitely use some going over. So this question gives us a triangle and says one side, again, I made these numbers up. Yours should be similar numbers, but the same format of problem. So it gives us a triangle, the perimeter of the triangle, and then each side length of the triangle, but represented in expressions in terms of the letter x or the variable x. So what we need to do if we have the perimeter is solve for x by making an equation out of the perimeter and these 3 sides. The perimeter of a shape is always the length of all the sides of that shape added together, right? So if this is A, this is side B, and this is side C, then A plus B plus C is going to equal P, or the perimeter. Good? All right, we don't have numbers or lengths for A, B, and C. Instead, we have values in terms of x. So A is 3x, so I'm going to put 3x here. Keep that plus sign. B is 5x plus 1. C is 4x minus 9 equals P, right? But we know what P is. They gave us P. In my case, P is 76. So they said the perimeter of this triangle is 76 feet or something. I'm not sure. Not sure what their units were. Now I have an equation. I found an equation because I know what perimeter means. Perimeter means I add the sides. I know what the sides are. The sides are 3x, 5x plus 1, and 4x minus 9. So I input that into my equation, and now I can solve this equation for x. Good? So now these, I've finished one step. My first step was I created an equation, right? I had 3 expressions and 1 value, and I created an equation out of those 3 expressions and that value. Now I'm going to solve that equation for x. So I'm going to combine like terms, the 3x, the positive 5x, the positive 4x, all become 3 plus 5 is 8, plus 4 is 12, right? So I have 12x, and then the 1 minus 9 becomes minus 8 equals 76. Good. So that becomes 12x minus 8 equals 76. Going to continue solving by adding 8 to both sides. 12x equals 76 plus 8 is 81. 76 plus 8 is 84. Yikes. All right, now I have 12x equals 84. 84 divided by 12. Just put that into my calculator. I get 7. X is 7. Good. So what we did was we made an equation out of the expressions, solved that equation for x, but that is not the end. They did not ask us for x. They asked us for the length of each side. So again, we have side A, side B, and side C. Side A was 3x, right? But now I know what x is. X is 7. 3 times 7 is 21. Good. Side B was 5x plus 1. So that becomes 5 times 7 plus 1. 5 times 7 is 35, plus 1 is 36. Good. And my side C was 4x minus 9. Will be the value of side C, so that'll be 4 times 7 minus 9. 4 times 7 is 28. Minus 9 is 19. All right. So I have my three sides. Side A now is 21. Side B, we decided was 36. And side C, we decided was 19. If I add those together, do I get 76? 21 plus 36 plus 19 is 76. So that works. Good. So we made an equation, solved the equation for x, replaced x with x, or sorry, replaced x with the answer we got for each side. So your answers are going to be, and I think they asked for them in ascending order. So it would be 19, 21, and 36. I labeled them A, B, and C randomly, but it turns out C was the smallest side. So I'm going to start with the 19. Good. So that's one of the quiz questions. The other one, it's slightly different than this, but one number, we're going to try to solve this one. If one number is 4 times a first number, a third number is 150 more than the first number, the sum of the three numbers is 420. So just like here, we had 3x and 5x plus 1 and 4x minus 9, we set it equal to 76, equal to our total, okay? Let's look at this one. One number, remember, if they never tell you what the value of this number is, we need to set it as our variable. One number is 4 times, a first number. That is different, right? A first number is different from one number. Those are two separate numbers. One number is 4 times a first number. A third number is 150 more than the first number. The first number and a first number are the same, okay? These are not necessarily 3 different variables, okay? But they are 3 different expressions, right? Here you could say one side is 3 times a number. Another side is 5 times that number plus 1. A third side is 4 times that number minus 9. Okay, that's what they're doing. They're making 3 different expressions, but those aren't necessarily 3 different variables. If you want them to be, you can make them A, B, and C. But really, we're just creating 3 different expressions, but all with that same variable, only one variable. Okay? So you're going to take that original number as your variable. I'm going to say it again. One side is 3 times the number. Another side is 5 times that number plus 1. A third side is 4 times the number minus 9. So this is the number, the number, the number. Okay? We gave them A, B, and C because they're different expressions, but you only have one variable when you write it all out. And then you have your total. Good? So same thing here. One side or one number is 4 times a first number. A third number is 150 more than the first number. The first number is what we decided is x. Okay? The sum of the 3 numbers is 420. So a third number is 150 more than the first number. Good. One number is 4 times a first number. And then we have that original, because there are 3 numbers, we need that original first number. Okay? So we started with the first number. We don't know what it is, so we made it x. That's the first number. A first number and the first number, x. One number is 4 times that first number, so we call it 4 times x. A third number is 150 more than the first number. The sum of the 3 numbers is 420. Good? So the sum means I'm going to add them, and there should be 3 numbers to add. When I add them, it will equal, 420. Good. One number is 4 times a first number. A third number is 150 more than the first number. The sum of the three numbers, right? I only have two right here. I have the 4x and the 150 plus x, but there were three. So I'm going to bring that original first number in. One number is 4 times a first number. A third number is 150 more than the first number. And we include the first number because there are three numbers. Good. It's fine if you rewrite it as a first number, because they call it the first number, plus 4 times that number, plus 150 added to that number. Good. 150 more than. 150 more than the first number equals 420. Now, just like last time, I'm going to combine like terms. We have x and 4x and x become 6x plus 150 equals 420. I'm going to subtract 150, subtract 150. Good. 420 minus 150 is 270. Now I have 6x equals 270, right? Divide by 6, divide by 6. 270 divided by 6 is 45. X is 45. Good. Let me pause and see what they ask us. All right. All right. Again, they ask us for all three of those numbers. So we found the first one. The first one is 45. So one of the numbers, the three numbers are, good. We found 45. Now we need to find the other two. There was 4 times x. 4 times x is 4 times 45. 180. Good. And then the last one is 150 plus x, which is 150 plus 45. 150 plus 45, I think, is 195, right? Because 5 plus 4 is 9, 0 plus 5 is 5, 195. So if I add these three numbers together, do I get 420? 45 plus 180 plus 195. 420. So the three numbers are 45, 180, and 495. So this is a challenging one. You kind of want to highlight what they're asking, right? One number is 4 times the first number. You have that first number. A third number is 150 more than the first number. The sum means we add them. The sum of the three numbers is 420. Good. All right, third one. These are hard also. 3 consecutive even integers. An integer is just a number that is a whole number. It does not have a decimal point, or sorry, it does not have numbers after the decimal point, and it is not a fraction in its lowest terms. Good. So it could be negative, it could be positive, it could be the number 0. If twice let's just read it first. If twice the first integer added to the second is 134, 132, find the three integers. Okay, we know what an integer is. They are also 3 consecutive, means they are in order. All right, 1, 2, 3 is consecutive, but consecutive even integers is 2, 4, 6. Okay, but it's anything. We don't know where we're starting, right? This is consecutive even integers starting at the number 2. It could be consecutive even integers starting at the number 166, okay? So 3 consecutive even integers, but we don't know which ones they are. We just know that it's going to look more like this. It's not going to look like this because the 1 and the 3 are not even, all right? 3 consecutive even integers. If I was to write this as an expression, right, I would have the first number, n. In this example, n is 2. Then the next even integer is that 2, but I need to add 2 to it to get to the 4, right? So n plus 2, and then n plus 4 are 3 consecutive even integers. That would be my equation, or how I would represent, it's not an equation, these are 3 separate expressions to show consecutive even integers. There's your original number. Let's say my original number was 40, right? The next consecutive even integer is 40 plus 2. The next consecutive even integer is 40 plus 4. So that becomes 40, 42, 44. This will always work if you start with an even number. Good? Or 0. All right. So that's what they're saying by consecutive even integers. If I needed to represent consecutive even integers, that's how I would write them in one variable. It could also be x. X plus 2, x plus 4. Good? Okay. So we have x plus 2, and we have x plus 4. So this is my first integer. This is my second integer. This is my third integer. When we had the triangle and I decided the sides, it didn't matter which one was first, second, or third side, right? Here we have one number and then we have a first number. So we know this is first, and this is third, right? A third number is 150 more than the first number. But here it did not matter. Here they told us the order. Here it has to be in numerical order, right? This is the first number, this is the second number, this is the third number in order. Consecutive means that they are in order. So my first number must be my smallest number. My second number is that first number with 2 added to it. My third number is that first number with 4 added to it, okay? So those are 3 consecutive even integers. If, okay? So my first integer, if I had to write it in terms of a variable, in terms of x, I would just call it x, or I would just call it n, okay? Let's write it. Second integer. How would I write that if I had to write it in terms of x? My second integer is x plus 2 so that it stays even. If this is 72, my second integer would be 74. My third integer would be 76. Good? So my third integer is x plus 4. So that is what we are using. You can even put parentheses around them. This is what we're using anytime they're talking about the first integer, the second integer, and the third integer, right? Now let's read what they ask us to do with those integers. If, good? If twice the first integer, if this is my first integer, twice the first integer, twice means 2 times, right? First integer is just x. There's twice my first integer. Added to the second. We already know the second integer is x plus 2. So twice the first integer added to the second integer is 1, 3, 4, 1, 3, 2. Okay? So let's bring it down. Twice the first integer added to the second integer is means equal. So I'm going to write it again. 2 times the first integer plus the second integer is 134,132. Good. So that was definitely the hardest part, right? Translating all of that into one expression. 2 times x plus 2 equals 134,132. Does that feel okay? So we translated all of that English into one math expression. Now we're just going to solve for x like we've been doing. 2x plus x becomes 3x plus 2 equals 134,132. We're going to subtract 2. We get 3x equals 134,130, and then we're going to divide by 3. Good. 134,130, not 32, divided by 3 is 44,710. Okay. So x is 44,710. They're going to want to know what the second integer is. That is 44,710 plus 2. The third integer is 44,710 plus 4. Okay, so those are my 3 integers. First integer, second integer, third integer.